Hello viewers, in this video we will talk about the box plot. Now I will first show you how to draw the box plot using ggplot function, and then we will delve into the details on how to interpret the box plot and what conclusions we can draw from the given dataset. Fine, so let's start with loading the tidyverse library tidyverse. And the dataset I'm going to use is a housing price data. So let me create a data frame housing underscore price, read.csv, and the name of the file home prices.csv. The dataset you can also find on the GitHub repository. I've put in the link in the description of this video. So let us view this dataset. Head housing price. Right, now you will find out that this data is related to the housing prices, and you will see number of variables on which the sale price of the house is decided. For example, the number of bedrooms, the living area, the year in which this property was built. All these are the independent variables, and the sale price is dependent variable. So that's how I can interpret this data. Fine. So now I would be interested in looking at the distribution of the sale price of the house against the number of bedrooms the house has. And I'm going to use the box plot to check this distribution. Okay, so now let's use the ggplot function and let's plot the box plot. Okay, now the first layer of the ggplot function is always a data layer. So ggplot data equal to housing price, and the second layer shall be aesthetic layer with x-axis showing the number of bedrooms and the y-axis showing the house price. So aesthetic x equal to bedrooms and y equal to sale price. Right. Now the one thing to remember here is that the variable on x-axis, that is the number of bedrooms, is the numeric variable in the dataset. So this is the numeric vector in the dataset. So it has the values 3, 4 or 5. And ggplot does not know how to use this numeric version of the number of bedrooms to plot the box plot. So what we have to do here is to convert the bedrooms to a factor. And by converting the bedrooms to a factor, the ggplot will treat now bedrooms as a factor inside the aesthetic statement instead of the numeric vector. Okay, so let's now convert the bedrooms to a factor using a factor function. So factor bedrooms, right? And the last layer will be the geometric object. In this case, geom box plot is the geometric object. Fine, great. Now we got 3 box plots here, one for 3-bedroom house, one for the 4, and one for the 5-bedroom house. And on the y-axis you see the sale price. Now let's take an example of this 4-bedroom house and let's try to interpret this box plot. Now first thing to remember is that the box plot uses the 5-number summary to visualize the shape of the distribution of continuous variable. Okay, so the box plot always shows the 5-number summary. And which are those 5 numbers? The first number is the median. The horizontal line drawn within the box represents the median. The horizontal line drawn on the top of the box represents the third quartile or Q3 of the data. So this third quartile covers 75% of the data range. The horizontal line drawn on the bottom of the box represents the first quartile, or the Q1 of the data. So this Q1 covers 25% of the data range. And if you see the box width, it goes from the Q1, that is 25th percentile, to Q3, that is 75th percentile of the data. And this box width is also known as interquartile range, IQR. And the median line represents the 50th percentile of the data. It's the median, so it's the midpoint of the data. So if you see the box contains middle 50% of the values. So we saw 3 numbers out of 5. Number summary. The first is the median. The second one is the Q1, which is 25th percentile. And third one is the Q3, which is 75th percentile. Now the lines that you see extending from each side of the box, they are called as whiskers. From above the upper quartile, from Q3, a distance of 1.5 times the IQR is measured out, and a whisker is drawn up to the largest observed data point from the dataset that falls within this distance. So the point where the whisker ends is the largest observed data point from the dataset that falls within 1.5 times IQR range, measured from top of Q3. So that is our fourth point. And similarly, a distance of 1.5 times IQR is measured out below the lower quartile, below the Q1, and the whisker is drawn down to the lowest observed data point. So this point, lowest observed data point from the dataset that falls within the distance. So this lowest observed data point is our fifth number. So now we have 5 number summary. We have Q1, we have median, Q3, and these 2 endpoints at the whisker lines. Okay, and these small dots that you see, these are the observed data points outside the boundary of whiskers, and they are called as outliers. So these points are called outliers because they are falling outside the range of whiskers. Now let's try to interpret the box and whisker plot for the 4-bedroom house. What conclusions we can draw? Now the first thing you can see here is the median line. This median line is approximately at the center of the box. So the distribution of sale price is fairly normal, right? And the sale price ranges from 200,000 USD to 470,000 USD, excluding the outliers. And the middle 50% of the sale price is between 300,000 USD and 370,000 USD. So 50% of the houses have the sale price in the range of 300,000 USD to 370,000 USD. If you consider the bottom 25% sale price, those houses which are fairly low in price, they are from 200,000 USD to 300,000 USD. But those houses which are selling at a very high price, the top 25%, the price ranges from 370,000 USD to 470,000 USD. Those prices are very high because the houses are built maybe in the upscale locality. And there are few houses which have exorbitantly high price, these outliers, and bottom low price, these outliers. They are denoted by the points outside the whiskers. Great. Now looking at the sale price between 4 and 5 bedroom houses, you can immediately notice the median sale price for the 5 bedroom house is more than the 3 and the 4 bedroom price. That's obvious because you have more built up area for 5 bedroom houses than you have for 3 and 4 bedroom houses. So the median price is higher for the 5 bedroom houses. But interestingly, if you see, the median price for the 3 bedroom house is almost the same as the 4 bedroom house, and the sale price variation for the 3 bedroom house is much lower than the 4 bedroom house. You can see that the whisker lines are much shorter in length than for 4 bedroom houses. So in short, box and whisker plots is a visual representation of summary statistics. Now so far we have made a box plot for a single variable. We can also make a box plot for multiple variables. Now if I want to check the movement of house sale prices over the years against the number of bedrooms, we can create the group box plot as follows. So we are now including the second variable, the year variable, and I'm checking the movement of sale price across the years for the 3, 4 and 5 bedroom houses. So let me copy the code. Now in the aesthetic layer, we need to use the function called interaction. Okay, so interaction factor bedroom. Now we are going to use the interaction between two variables here, the bedroom and the year built and the year in which the house is built. So factor bedrooms, remember we need to convert both the variables into factors. Factor bedrooms, comma, factor year dot built, and y equal to sale price. So that won't change. Geom box plot. Right, perfect. Okay, so what we can see, we can see that the separate box plot is shown in each year as per the number of bedrooms in the house, and these box plots are grouped as per the number of years. So if you observe on the x-axis, you will find that 3 box plots for each particular year. Okay, and if you see this year, interestingly, 1951, the median sale price for 5 bedroom houses is much lower than 3 and 4 bedroom houses. Now why that could be? Because you can see the distribution of this 5 bedroom sale price is right skewed. So more than 50% of the houses have the sale price higher than the median price. So you see a lot of, and also you see a very long whisker drawn out of Q3. That indicates that it has most of the houses which are of high price, and this long whisker tells us that the distribution of 5 bedroom sale price is highly right skewed. So you can see a lot of information hidden in this plot, and you can also compare the 5 number summary statistics for each bedroom house over the years in which the house is built. Great. Now so far we have seen the summary statistics of the data. One of the limitations of the box plot is that the box plot doesn't show us the distribution of the data. And the distribution, what I meant is that if I want to check whether the observations are clustered around the mean, or whether the observations are clustered around the minimum and maximum value of the data points with nothing in the middle. So overall, how the distribution looks like of the data. These questions cannot be effectively answered using the box plot. So if we are interested in distribution, then we need to use the violin plot. Now, violin plots are the way of comparing the multiple data distribution. Right, so let me show you how to draw the violin plot first. I'm going to copy the same code, but the only one change that I'm going to make here is that instead of geom histogram, I will be using geom violin as a geometric object. So let's see what we can get. Yeah, now first thing you need to remember is that this violin plot is a kernel density estimate, and this kernel density estimate is mirrored so that it forms a symmetrical shape. So you can see that these three violin plots have the symmetrical shape. Now, what is kernel density estimate? Kernel density estimate roughly is nothing but a smooth version of the histogram. And looking at this violin plot, you can notice that the sale price of the 3-bedroom house is centered around the min, and it has a less spread, whereas the sale price for the 4-bedroom house is having a high variability and the distribution is right skewed, with the outliers pulling the tail of the distribution towards the right. And these flat tails that you see of the violin plot, they show the outliers in the data. It is also good practice to show the narrow box plot overlaid on the violin plot. Now, in the next code that we will going to write is to show the box plot overlaid on the violin plot. So let me copy the code first. Let me copy the earlier code first. And here I'm going to use the box plot as another layer on the top of violin plot. And here I'm going to use the geom box plot layer. I'm going to change the width of the box plot to 10% so that I can fit this box plot neatly inside the violin plot. And I'm going to fill the box plot with a black color. Now, because the box plot is filled with the black color, you won't able to find out the median line. So I'm going to show the median line with a point. So I'm going to add another layer, a statistical summary layer, stat_summary. I'm going to use the median function for the y-axis. So function.y equal to median. Geometric object is a point. I'm going to fill the point with a white color, shape equal to 21, size equal to 2.5. So let me execute this. Yeah, now you can see that the violin plots are overlaid with the narrow box plots. So here you see the 5-number summary stat in the form of box plot, as well as the data distribution in the form of violin plots. So these kinds of box plots overlaid on the violin plots are extremely important when you carry out the exploratory data analysis to check the distribution of the data and also to check where the medians are and how in general the data looks like in terms of quartiles, in terms of interquartile ranges. Right, so let's summarize the discussion quickly. The box and whisker plots uses 5-number summary to visualize the shape of the continuous variable. The 5-number summary is the median, the first quartile, the third quartile of the data, and the 2 extreme points of the whisker lines. The outliers in the box and whisker plot is shown as dots, and those outliers always fall out of the range of the length of the whiskers. Box-whisker plots are plotted using box geometric object. Box-whisker plots does not show the distribution of the data. So that's one of the limitations of the box-whisker plots. And if you want to see the data distribution along with the summary stats, then we will have to use the violin plots. Violin plots are plotted using violin geometric object, and it's a good practice. Violin plots are always overlaid with the narrow box plots. Thank you very much for watching the video till end. If you are liking this video, then you may like to subscribe to this channel, and also leave your suggestions, comments in the comment section. That would really help me to improve the content. Thank you again, and I will see you soon.